The James Webb Telescope is challenging our long-held assumptions. It has already detected several galaxies that are far too large and massive for their early stages of formation. This raises an important question. If our models of early galaxy evolution are flawed, could we also be misunderstanding the origins of the universe itself? Although the Big Bang theory has been widely accepted for years, it is now facing growing criticism. It's possible that the Big Bang was not the beginning of everything, but merely one of many transitions in a never-ending cosmic cycle. This leads to another intriguing question. What existed before the Big Bang? Our universe began as a hot, dense state nearly 14 billion years ago, and from there, it started expanding. Most people, even fans of the popular sitcom, The Big Bang Theory, are familiar with this concept. According to our current understanding, the Big Bang represents the moment when space, time, and matter emerged from a singularity about 13.8 billion years ago, giving rise to everything that has ever existed or will exist in the future. But how can we know what happened so long ago? The answer lies in looking back at the development of the universe since that moment. The cosmos is not a static entity, it has been expanding ever since its creation. To better understand this, we need to recognize that the universe isn't expanding into pre-existing space. Rather, space itself is growing. If we trace this expansion backward in time, using Einstein's theory of general relativity, we arrive at a point where the density of matter and energy becomes infinite, and spatial distances shrink to zero. This takes us back to the dense state from which the universe began. Theoretical calculations aren't the only thing supporting the Big Bang theory. There's also the cosmic background radiation, microwave radiation created about 380,000 years after the universe's birth, which still fills the universe today. The fact that this radiation was predicted in the Standard Model and then detected serves as crucial evidence for the Big Bang. However, the Big Bang raises more questions than it answers. According to our models, the early universe underwent a massive growth spurt, expanding by a factor of 10 to the power of 30 or even 100 in a fraction of a second, a phenomenon known as cosmic inflation. Yet, how exactly this happened, and whether it even occurred, remains uncertain. This brings us to another fundamental question. Was there something before the Big Bang? The Big Bang theory alone doesn't resolve all cosmic mysteries. For instance, what caused something to emerge from nothing 13.8 billion years ago? Was it triggered by a specific event, or was it purely coincidental? How can matter arise from nothing? Stephen Hawking addressed these questions in a simple yet profound way, suggesting that asking what came before the Big Bang is as pointless as asking what lies north of the North Pole. According to Hawking, time itself began with the Big Bang, meaning it could not have been caused by anything. But not all researchers agree with Hawking. Another major question is why matter and radiation are so evenly distributed throughout the universe, no matter where or how far we look. Some experts attribute this uniformity to cosmic inflation, but others propose that the inflation process is still ongoing, leading to the formation of multiple parallel worlds. As a brief conclusion, it's clear that despite its widespread acceptance, the Big Bang theory is not without controversy. Over time, alternative theories have emerged that attempt to explain the origin of the universe in entirely different ways. Although these theories vary greatly, they share a common idea: the Big Bang may not have been the start of everything. Some scientists believe there was a universe before the Big Bang, and that the event was simply a transition from one cosmos to the next. In this case, it would be more accurate to describe it as the Big Bounce. What evidence supports the existence of such a cyclical universe? The concept of creation and destruction cycles is not new. Ancient Indian texts, like the Vedas, describe the universe as undergoing continuous cycles of creation, destruction, and recreation. Even Einstein considered the possibility of an oscillating, cyclical universe, believing that what expands could also contract. Cyclic models are still popular in cosmology today because they bypass the problem of a cosmic beginning. If matter has always existed in an eternal cycle, the question of how something can come from nothing becomes irrelevant. In this scenario, the uniformity of the universe could be explained by cosmic contraction, which would evenly distribute everything. The Big Bang, then, could be seen as the end of one cycle and the start of another. However, there's a major problem with this theory: entropy. According to the second law of thermodynamics, the disorder in a closed system always increases. With each new cosmic cycle, entropy would rise, leading to a universe that eventually reaches maximum entropy, where no atoms, stars, or galaxies could exist. Despite this, scientists have found a potential solution. The answer may lie in a concept known as loop quantum gravity, which suggests that spacetime is not continuous but consists of tiny, indivisible units. This theory prevents the existence of infinite densities, meaning the original singularity of the universe could not have existed. At the moment of the Big Bang, gravity is thought to reverse, pushing everything outward instead of pulling it inward. In this loop model, the Big Bang was not the beginning of everything, but a transition. Each new universe would essentially start fresh, with no memory of the previous one, solving the problem of entropy by resetting it to zero. Thus, every new universe would begin anew, free from the limitations of the past. Feel free to hit the like and subscribe buttons to become part of our community, and never miss another video. We'll see you soon.